In number 7, we're trying to figure out if this is really a right triangle or if it's an acute or an obtuse triangle instead. And so we're going to use the Pythagorean theorem again and set it up as if this Pythagorean theorem is going to work, as if a squared plus b squared really is equal to c squared. And if it is, great, then it's a right triangle. But if one side ends up being larger, for example, if a squared plus b squared together is larger, then it'll be an acute triangle. If c squared ends up being the larger side, and these sides aren't really equal, then it would be an obtuse triangle. So let's plug values in here to see if they really do balance and it's a right triangle, or if one side's greater than the other. And the first thing we need to identify is what's the longest side. It looks like this is the longest side, but you might have to plug in 3 times the square root of 13 into your calculator. You find out it ends up being a little bit more than 10. So yes, it really is the longest side, which means that's going to be our C value. In other words, if it was a right triangle, it would be the hypotenuse. Okay, so we're going to plug that value in here. 3 times the square root of 13 is C, and we're taking that and squaring it. Okay, then the other two values, the other two sides, it doesn't matter what you call which one. I'll call A 5, we got to square that, and we'll call B 6, and we're going to square that. Okay, so now it's just a matter of working through the algebra to see how those sides really compare. 5 squared is 25, 6 squared is 36, and then here we've got 3 times the square root of 13 squared, which is really like 3 squared, that's 9, times the square root of 13 squared, which is 13. And when you take 9 times 13, you get 117. Okay. When I add these two sides together, you see I'm nowhere close to 117. We're at 50, we're at 61, and that's compared to 117. So this isn't really equal at all, is it? In fact, this side is much greater, and that was the C side by itself, which means we've got an obtuse triangle here. If they had been equal, it would have been right, but since that side's larger, obtuse.